Let's read this question first. Look, it says, given that tan x is that, huh? Tan x is that. I've given you the tan. Use it. Figure out where tan is. Remember, add sugar to coffee. This guy's actually negative. But look at this. This tells you specifically it's not in here and in here. This is your restriction telling you pi over 2 to pi. It's got to be in the second quadrant. Ah, easy peasy, right? Yes, draw the angle out here. This one is a no-go because it's not within this nice little domain setup, right? Perfect. Here's your theta reference, or in this case, since it's angle x, this is your reference angle XR. Perfect. There we go. Now, how do we figure out all the sides of this triangle, and why do we have to figure them out? I'll show you in a second. Watch this. You know and I know that tan is opposite over adjacent. There's the op, there's the adj. Beautiful. Opposite being over here, 2, adjacent is 3, but you're looking at this and you're going, well, where's the negative? Well, one of the reasons why I put them both down as absolute values, as positive values, is because I determine the negative based on what quadrant it's in. Look, zoop, that's negative, that's positive. The way it's written here with the negative up front, you can't really tell. So now all I have to do is find this wonderful hypotenuse, don't I? And that's based on, you betcha, Pythagoras. Excellent. So I got my a squared. I have my b squared equals to c squared. This is 4. This is 9 equals to c squared. 4 plus 9, of course, is 13. There's c squared, square root, square root. Guess what? I know you want to put plus or minus root 13, but the important thing is this is a radius. Radiuses are never negative. Okay, so what does this mean now? Well, guess what? I have all the primary trigonometric ratios that will help us in our sine and cosine. Like, look at this. Look, they're all primary trigonometric ratios, right? So let's figure out every single one of them. Well, you all know that tan x equals to negative 2 over 3. But look, I can now write down what cos x is. Cos x is adjacent over hypotenuse. Cos x is negative 3 over root 13. I can even put down sine x because you know and I know that the sine of something like this is going to be the opposite over hypotenuse. Look at that. And check out the cast rule. Both of these are negative. According to the cast rule, that's positive, and sure enough, the sign is positive. Now, how do you use this? Real easy. Check this out. This is sine 2x. Well, let's clean this up here because I don't want this stuff to distract me. Look what I have here. Look at this. Sine 2x, which is the only identity is this guy right here. So all I have to do is go, okay, 2 sine A cos A. Okay, well, this is the same way as saying 2 sine x cos x. Look, this is an x value. So, okay, these are x values. Whoopie-doo. Okay, x and x. Well, the nice thing is I have sine x right here. I have cos x right here. So this is 2 times the sine of x, which is, oh, that's 2 over root 13. Beautiful. Cos x is minus 3 over root 13. Straight out multiply. Look at this. Straight out multiply all the way through. 2 times 2 is 4 times minus 3 is minus 12. Root 13 times root 13, of course, is just plain old 13. There's your first answer. Wow, that was just way too easy. Okay, perfect. Let's go to the next one. Check this out. Now, I want to have these identities showing, so it's going to be a little bit of crunchiness here. But let's go. Let's look at cos 2x right here. Always pick the first one. That one just, I don't know. The other ones are just part of the Pythagorean theorem, right? So use the one that's most common, which is this one. So look at this. This will be, well, it's no longer a's, they're all x's. But look what you have. You have cos 2x equals to the cos squared of x minus the sine squared of x. Okay, so that just means take your sine and your cos and square them. Look at this. There's your cos, which is minus 3 over root 13. You're going to square it. And this is going to be subtract the sine squared, which is, oh, look at this guy. This is going to be, look at that, 2 over root 13, and that's going to be squared. Okay, let's solve this. This is going to be, of course, that's going to be equal to 9 over 13. Just square it. Square 3 is 9. Square of root 13 is 13. Minus the square of 2 is 4. The square of root 13, of course, is going to be 13. Look at this. 9 minus 4 is going to be 5 over 13. And there's your answer. Well, that's super simple now. Let's see if we can do tan x, which is the last one. Well, I can't see my identities, so I want to move that down. Okay, hold on. Obviously, I'm dealing with tan now because it says tan 2x, so I'm dealing with this identity right here. So let's use it. Okay, tan 2x. So every a is now an x. Yippee skippy. Okay, so tan 2x means, look, 2 times the tan of x. What is the tan of x? Ah, there it is. Okay, this is minus 2 over 3. Perfect. This leaves you with 1, okay? 1 minus the tan squared. I don't know if you can read that or not. I put too much. Oh, it is tan squared. Look at how nice that is. So you're going to take, again, the tan, which is this guy, and you're going to square it. Okay, so that's minus 2 over 3, and you're going to square it. Oh, that's not tough at all. Look, this becomes, think about it, minus 4 over 3 divided by, okay, this is 1 minus, and yes, because this is in brackets, even though this is squared now, right, it becomes a positive 4 over 9. Be careful, be careful, be careful. So you got minus 4 over 3. Make this into a common denominator of 9 over 9 minus 4 over 9. This is minus 4/3, and I'm just going to write it like this now just to keep it nice and simple. Divided by, because that's what this line means, 9 over 9 minus 4 over 9 is divided by, you got it, 5 over 9. Oh my goodness. Take the reciprocal, multiply. Check this out. 3 goes into itself once, into 9 3 times. Minus 4 times 3 equals to minus 12. 1 times 5 is 5. And there's my answer. Isn't that pretty? Oh my goodness. And it's all based on the double angle identities. Probably the most important thing to do is make sure you've got this in front of you. It's on your formula sheet. Always have your formula sheet right by your side.